Hi, I am Rachel Meliodas. I'm a senior editor at O'Reilly, and I am interviewing Eric Lippert. He is a principal developer on the C# compiler team at Microsoft. Hi, Eric. Thanks for joining me.
Hi, Rachel. It is good to see you. It is good to actually finally put a face to the email.
Yeah, same to you. Same to you. So I'm just going to dive right in. Where do you see a lot of C# coding being done lately? Do you see it in data apps? Do you see it in web apps?
We see it in everything. We see it throughout the Windows ecosystem, and I think that is totally awesome. I answer a lot of questions online from C# developers, and we get questions about C# on Xbox 360. We get questions about C# on Windows phones. We get questions about active server pages. The whole bit, everything from games to data-driven line of business applications, and that is really exciting for me. Like, that's why I come to work every day. It's because I get to work on something where the code that I work on enables millions of people to make really cool stuff.
Yeah, it's definitely exploding on our end from a publishing perspective. So what do you think, with people using it in a variety of ways, what do you think C#'s strength is?
Well, I can't give you just one strength. I mean, because it's so there's so much there. But let me give you three. All right. So the first one is that C# is highly general. Right. Like I was saying, you can write everything from Xbox games to great big websites in C#. It's not a domain-specific language like a lot of languages are. Second, we design C# very carefully with the needs of modern professional developers in mind. So let me just give you an example. Like, we knew from day one that C# was going to be used to make component-based software that needed to be versioned over time. And so we've made a lot of subtle decisions in the design of the language that make it easier to write software that's going to be changed in the future without breaking things. And some of those decisions are counterintuitive. And I talk a lot about that on my blog, where I write a blog about language design. And the third thing that I think is a real strength of C#, or maybe what sort of leads to C# being a strong language, is that the language designers are first and foremost pragmatists. They're not ideologically driven. Like, we don't ask ourselves, oh, we have this proposed new feature, is it object oriented? Right? That's the last thing that's on our mind. We look at, does this problem, is this a real user problem? Does the feature solve it? Will solving this problem in a particular way prevent us from solving problems, in the future? We don't want C# to be, one of these everything but the kitchen sink languages that doesn't hang together well. But we do want to, look at object-oriented design and functional design and procedural design, and take ideas from those disciplines and make them work in the language.
Okay. Yeah, no, it's definitely covers a lot of ground. So in C#5, there's a new thing called async. Why should developers be excited about this?
Well, let me back up for a minute and just briefly describe what the feature is. People like me are excited about this feature because it's cooperative multitasking via coroutines implemented using continuation passing style, and that's enough to excite me. But like that, the coolness factor does not really excite your typical line of business developer, because that's just a whole lot of computer science jargon. So I want to think about what's the actual problem we're trying to solve here. And the problem is that we live in a world with latency. And by latency, I mean you want to write a program that needs to solve a particular problem, and the solution is only going to be obtained billions of processor cycles in the future. And that's due to one of two causes typically. Either the answer that you need is on a server in Japan, and that signal is moving at 1 foot per nanosecond, and so there is just simply the fact that we have the laws of physics to deal with. That means that there's going to be latency in the operation. Or the problem that you're trying to solve is one that just simply needs a lot of calculations, billions and billions of calculations. And maybe those calculations are being performed on another core or on another machine in your network or whatever. But it's just simply going to take a while for the result to come back. And so typically the way people solve this problem in the past is they end up writing programs that split their work up into small chunks. And if one of those chunks needs to do something that's high latency, they figure out, well, what chunks of code don't depend on that result? And let's keep running that code while we are waiting for the result to come back. And that's great. You end up making efficient use of your processors that way. But it makes your code hard to understand. It makes it hard to debug. The logic gets all upside down and backwards and inside out. So the point of the async feature is that it allows you to write your code in a sensible, this happens, this happens, this happens, this happens order. You annotate points in the code with the keyword await that mean it's possible that a high latency operation is going to happen right here. And then the compiler takes care of splitting the code up into chunks, and the runtime takes care of scheduling them all appropriately. Right, so that was a long answer to your question, but why should people be excited? Because people write code that deal with latency. Almost everybody does now.
Right.
And async makes it so much easier to write code that makes sense.
Well, it seems so. I know that people that I've talked to are excited about it. So, Next question. What is up with Rosalyn?
Rosalyn is the project that I work on myself right now. We have had actually 2 C# compiler teams running in parallel for a couple of years now. One of them has been working mostly on async, and one of them has been working on Rosalyn, and I've been working on the Rosalyn one. Rosalyn, the idea is we are rewriting the C# compiler and the VB compiler in C# and VB. And that's maybe not super compelling for users. Like, what do you care what language your compiler is written in? The interesting thing about that is we want to make the C# and VB compilers, and specifically the analysis engines that they use, we want to make those available to our customers so that our customers can also write code analysis tools. And we don't think that just anybody's going to do this. We don't expect the typical line of business developers are going to use Rosalyn. What we expect is that by making these rich code analysis tools available to third parties, that we will massively improve the tooling infrastructure that's available. That more people will be more easily able to write programs that analyze code for correctness, look for bugs, do refactorings, do clever code editing solutions, all that kind of thing. So that's what I work on, and it's a really big investment, and we're putting a lot of time and a lot of energy into it because we want that tool space to really succeed.
Right. So, and that's forthcoming.
Yes. Yeah. We have not announced a schedule for that. We've done one community preview release so far, but we're not saying when the final release is going to be available because we don't know.
Okay, sounds good. So kind of along the same lines is, if you could tell people one thing about C# that they don't know, what would you want them to know?
I have a whole series of posts on my blog that are about dispelling myths about C# programming. And so, it's tempting to pick one of those and say, well, everybody seems to think that value types always go on the stack, but that's, in fact, a myth. Value types don't always go on the stack. But I think that maybe rather than digging into one specific technical issue, what I would tell people that they maybe don't know is your performance analysis needs to be engineering discipline. A question I get a lot is, which of these 2 pieces of C# is faster, right? And that's the wrong question to ask for 2 reasons. One is maybe how fast is it is not the right thing you should be asking. Maybe you should be asking how much memory does it consume, or maybe you should be asking what's its worst case performance, or what's its amortized performance, or whatever, right? But more generally, the question should not be which of these two pieces of code is faster. The question should be which of these two pieces of code is fast enough for my customer. And so whenever people ask me performance questions, I go right, I turn the question right around on them, and I'm like, well, first of all, if you want to know which of these two pieces of code is faster, run them, right? Get out of the stopwatch. You'll soon know which one is faster, because I don't know. That's how I would find out. But more generally, I really want people to develop an engineering discipline around performance. Performance is a feature, and like any other feature, you set goals, you write test cases, and finally, something I always tell people is, if you have already met your performance goals, don't waste your time trying to improve your performance, right? There are lots of other things that you could be spending that time on, maybe performance is not always the best bang for the buck. Maybe it is, but that's something that you've got to make an engineering decision that's data-driven.
Mm-hmm. Good answer.
Yeah.
And next I wanted to know, we've done a book recently on mobile development using the Mono tools and C#. Do you think C# is a good option for mobile development?
Oh, I think C# is an awesome option for mobile development, and Visual Basic is as well. We've gotten a lot of feedback on that. I do not do a lot of work with the mobile team myself, but I have a bunch of friends who are writing programs over in the Windows Mobile team. And they use a variety of languages, and they seem to, particularly enjoy using C#. Mm-hmm. So yeah, I think that's a really good option. And like I said before, C# is a general-purpose language.
Right.
We want it to be used all over the place.
Great. And one final question:
Sure.
Where do you see opportunities for improvement in the language in the future?
I get that question a lot. So, and I always have to preface the answer by saying, we have not announced any future language developments beyond C#5 and Rosalyn. We haven't announced what future language features will be, if there in fact will be any, and so on. Mm-hmm. So take everything that I say with a grain of salt. There's no promises here. This is me talking about programming languages, which I love to do.
Sure.
So all that said, there are two main areas that I'm really personally interested in exploring that I think maybe we could do more work on in future versions of C#. One is improving our support for functional programming, and the other is improving our support for metaprogramming. And functional programming has sort of two aspects to it. One is this idea that functions are data, and you can treat them like any other data. And C# already does that pretty well. We have lambda expressions, and we have lexical closures, and all that sort of. You can do functional composition, and so on. I don't think we need to do a whole lot more there. But where I do see some shortcomings in the language is in designing functional data structures that use immutable, persistent patterns. We've designed Rosalyn around sort of a functional, immutable data structure pattern. We've designed going back a couple of versions, we designed the expression tree support in LINQ to use a functional style. And though you can do that in C#, the language in some sense fights you a little bit. We could do better there. It's not clear how we could do better, but we probably could make it easier to reason about programs that are written in an immutable style. So that's one thing. And then metaprogramming is this idea that you can write programs that manipulate other programs in some way, and it's a huge topic. And this is on my mind because I'm working on Rosalyn, and Rosalyn is a great example of a program written in C# that manipulates other C# programs. In this case, it analyzes them. So I think about how we embedded LINQ into C#3. We essentially embedded a domain-specific data query language into C#. And could we add metaprogramming features that make those sorts of extensions easier? Or could we add features to the language or to the compilers that make it easy to go the other way, to say, well, we're going to take this hunk of C# and we're going to embed it in this other language, it's a markup language, let's say. Or, are there other ways to sort of programmatically extend the language or to improve the ability of the language to analyze itself? So we got a bunch of big general ideas like that, but we don't have specific proposals for features that we are taking out and showing customers. So I always encourage people, if you do have specific ideas for features, or just sort of general areas that you want to see us work on in the language, post them to connect.microsoft.com. And I also always caution people, when you do that, do not expect a detailed, individualized response, because we get thousands and thousands of those, and we don't have the manpower to respond to each of them in maybe the level of detail they deserve.
Sure. Well, that's great stuff. Thank you for talking to me. It was good for, I think, people new to C# and people that are experienced. And maybe we can do this again in the future.
I would like that very much.
All right. Fantastic.
All right.